If you come and visit me in London, you'll see streetscapes a bit like this. And if you see the world through my eyes, you'd see this. Don't pity me, okay? I love this stuff. We just make so many amazing materials as humans. In fact, that's what we do. We have done that for thousands of years. We make stuff. At the first, we made tools, which allowed us to make clothes, and then it allowed us to make shelter to protect us from storms and from the weather, and containers allowed us to store food so we could survive the winters. And then we started to dream big. We started to make boats, and we started to make materials that cured toothache, and we made stuff that could harness electricity, and we made airplanes, and we made stuff that could go to the moon. I mean, this is who we are. We make stuff, and here it is. Why do we make so much stuff? Why? Well, it represents who we are. This is who humans are. We like to make stuff. We like to dream big. We like to create. So that is why civilization gets pushed forward. It's why the ages of civilization are named after materials. We have the Stone Age, we have the Copper Age, we have all the ages until now. But there's a problem. You're all familiar with an image of a pothole. You've all driven straight into a pothole, or, on a bike, been thrown off your bike by hitting one of these potholes. They're a menace. If you're on an e-scooter, you just disappear right down them. All of our stuff, we've got so good at making it, but we're not so good at repairing it. We're not so good at taking care of it. And that is our next big task, our next adventure as humans, I think. So what would a future like that look like? Imagine a city now of the future, but imagine one that doesn't constantly fall apart, that doesn't constantly have potholes and cracks in bridges, that when a storm hits and it's damaged, then it heals itself. What would that be like? Could we do it? Can we make bridges, tunnels, roads, buildings that repair themselves? The answer is some stuff called animate matter. And what is animate matter? Well, animate matter is a different form of material. We're borrowing from nature. It's a form of material that repairs itself, heals itself, actuates, senses the environment. Is it impossible to make? No, we're making it now. People in my lab, hundreds of people in labs all over the world are making this stuff called animate matter. But to tell you how it works, I first need to take you inside materials. I need to show you how they work. And this map of the world is perhaps unfamiliar to you, right? So this is how we material scientists understand the material world. This is how we design new materials. You got big stuff at the top, and you get smaller, 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 smaller. So on the left-hand side, you can see the natural world, how nature builds materials. You have trees, and then you have whales, and they have mice, and then you have the fleas on the mice, and they have the hairs on the fleas. And inside those, you have tissues. And there are many types of tissues. We have skin tissue, lips, we have brain tissue. And then you zoom in further, you get single cells. And then you zoom in further, and you get the whole molecular machinery of cells. And you zoom in further, and you get the DNA. And it's the DNA that builds those machines, and the machines that build the cells, and cells build the tissues. And so you get the idea. The way nature builds materials is that it stacks every layer on another, that they are all grown inside each other. Big stuff contains small stuff. We are multi-scale materials. And what is life then? What is it to be alive? Well, it's the connection between those scales. The scales themselves are physics and chemistry, but the stuff that connects them, the information, they check each other, they repair each other. If they find some damage, they repair that. And you're doing it now, right? You are repairing yourself now. You get a scratch, your body just goes to work repairing it. So nature builds materials, but it builds self-repaired materials. Now, we've built materials too. We build amazing materials, massive bridges, cars, phones. We've mastered these different scales. We can zoom in, we can make nanostructures, we can manipulate atoms, we can make transistors. But what we really lack is the ability to connect those scales up and get them to self-repair. And that is the big next challenge. Can we do it? Well, look, let me take you through some work that we're doing. We're already making great progress. So self-repairing roads. When we analyze the roads, we realize that big potholes start off as tiny microscopic cracks. And the key to stopping them doing runaway growth into a pothole is to catch them early. If you zoom in now, and we started to look at the different structures inside roads, what we found are maltines and micelles, and actually they can self-repair. They actually can move around, but you need to give them impetus, you need to give them energy. So we put embedded nanoparticles into that material, and by actuating it with magnetic field, we can get them to move around and self-repair the microcracks before they become potholes. Another example, self-repairing concrete. There are people in the world who've been making this for quite a while now. You can buy this stuff. How does it work? Well, inside the concrete are tiny microorganisms placed there by the concrete manufacturers. When a big storm hits and the crack opens up, the microbacteria wake up. They smell the humid air. They look around for food. They find starch that's been left there by the designers of the concrete. They eat it. They do a poo, and they poo calcite. Yes! They eat their way out of the crack, leaving pristine material behind them and restoring the concrete to 90% of its original strength. It works today. Self-disassembling plastic. So we've been working on this problem that you need to put plastic wrappers around small seedlings to grow trees to reforest the world. But the problem is the plastic itself then pollutes the world. So can we get a material that protects the tree for years on end, but when that tree is mature, will then disintegrate and become biodegradable? Answer, yes. We are embedding little tiny enzymes that catalyze the disassembly of those polymers, of those plastics. And we get them into the plastic by wrapping them in a random heteropolymer. And that allows them to survive the process, the high temperature process of making the plastic, and to survive in the environment until they're needed. And then they come out and it disintegrates. And we're field testing this now. So these animate materials that I'm talking about, they are really extraordinary. And they are possible now. We are making them. And they make self-repairing roads, self-repairing bridges, and biodegradable materials much more tangible in the future. So what are the problems we face? It's not so much the technical stuff. We can do the technical stuff. Probably one of the biggest hurdles is the economics. At the moment, we have a system where we make stuff, it falls apart, we remake it, it falls apart. And we throw the waste away into the environment. We do this with roads, we do this with buildings, we do this with electronics, we do this with clothes, we do this with pretty much everything. And we're basically just piling our materials, our wonderful materials, the ones that we've made over time immemorial, we just throw them away as if we don't care. And we've got to stop. We've got to take care of our materials, but we need a new economic model. The consumerist model doesn't work for a sustainable future, for a non-polluting future. And I think animate materials will play a really big part in making those future. And when you calculate the cost of that pollution and that global warming, then they'll start to make sense economically. So what would we feel like, though, to live in this world? To live in a world that is animate? Well, I think in 20 years' time, if you come to visit me in London and the animate materials are now in the infrastructure and in our phones and in our laptops, I don't think it will feel weird. I think it will feel a bit like being in a forest, right? You go into a forest, all of that stuff is looking after itself, repairing itself, building itself. In fact, we could push these animate materials to make themselves. Perhaps we could make roads that build themselves. And then what would our job be? Our job wouldn't be to constantly have to repair things, laboriously throw things away, remake them. Our jobs would be more like gardeners, right? Yeah, the city would look after itself. We could enjoy ourselves, occasionally pruning a road that was drifting off into the wilderness, yeah? Or it had rebuilt a bedroom of yours and you didn't quite like the design, you could push back on it a bit. But that is the world we're heading towards. That's the future. A future where we take care of our stuff. Thank you.